Hi everyone, Assalamualaikum. In this video, we will discuss higher order derivatives. Okay, let me start with the notation of higher order derivatives. Let y equals to fx be a function in terms of x. The following are notation for higher order derivatives. Right? The following table shows the notation of derivative. The first column is the notation of first derivative. The second column is the notation of second derivative. The third column is the notation of third derivative. The fourth column is the notation of fourth derivative. The fifth column is the notation of nth derivative. Okay, and then for the first row, okay, this is probably the most common notation. Okay, the second row is the notation under Leibniz notation. Okay, and so does for the third column. Alright, and the last column is the notation for Euler's. Okay, alright, for d2y over dx2, for example, is read as the second derivative of y with respect to x, and the 2's here in this notation are not exponent. Alright? Alright, for quick example, let us start this section with the following functions. Alright? Given y equals to fx equals to 2x to the power of 5 plus x to the power of 4 plus 3x squared minus 2x plus 5. Alright? By this point, we should be able to differentiate this function without any problems. Doing this, we get y single prime equals to f single prime x equals to dy over dx equals to 10x to the power of 4 plus 4x cubed plus 6x minus 2. Right? And then we can differentiate y single prime. So the symbol become y double prime or f double prime when we differentiate f single prime. Okay, or d2y over dx2 when we differentiate dy over dx. Alright, which is equals to 40x cubed plus 12x squared plus 6. Alright. Now, this is a function and so it can be differentiated. Here is the notation that we will use for that as well as the derivative. Right? This differentiation process can be continued to find the third, fourth, and successive derivative of fx, which are called higher order derivative of fx. Alright? So this is y triple prime or f triple prime or d3y over dx3, and we get 120x squared plus 24x. Alright? And after that, we differentiate from y triple prime, so we have y quadruple prime, or when we differentiate f triple prime, we have f quadruple prime, or when we differentiate d3y over dx3, we get d4y over dx4, which is equals to 240x plus 24, right? And then we can differentiate again. Okay, so we have y double prime triple prime equals to f double prime triple prime x equals to d5y over ds5, which is equals to constant 240. Alright? This process can continue, but notice that, okay, if we differentiate from y double prime triple prime, we have y triple prime equals to f triple prime x equals to d6y over dx6 equals to 0. Alright? So, when we differentiate d6y over dx6, okay, it also equals to 0. So this process can continue. But notice that we will get 0 for all derivative after this point. Okay, this set of derivative leads us to the following fact about the differentiation of polynomials. Right? Because the prime notation for derivative will eventually become somewhat messy, so it is preferable to use the numerical notation, okay, as follows. Alright. So for y quadruple prime, we can write y bracket 4, okay, and for f quadruple prime, we can write f bracket 4x. Alright. And for y double prime triple prime, we can write y bracket 5 or f bracket 5x. Okay, and so does for y6 and f6x, right? Alright, notice that for derivative of higher order than the third, okay, the parentheses distinguish a derivative from a power. For example, y4, okay, not equals to y to the power of 4. Alright? Okay, y bracket 4 is not equals to y the power of 4 because y bracket 4 here means the fourth derivative. And y the power of 4 without bracket or without parentheses means y to the power of 4. Alright? And f bracket 4 x not equals to f for x. Alright? Because f bracket 4 means fourth derivative and f for x means composite function. Okay? So fx composite with fx, composite with fx, and composite with fx 4 times. Alright? Alright. For f single prime or f single prime or y single prime or dy over dx, it is called first derivative. Alright? For f double prime or y double prime or d2y over dx2, okay, it is called second derivative. Okay, and then followed by third derivative, fourth derivative, fifth derivative, sixth derivative, and so on. Alright? So these are called higher order derivatives. Right? Alright, an example will show how it is all done. Okay, now let me discuss example 1. Okay, find the second derivative of y equals to cos squared x. Right? Alright, because y equals to cos squared x equals to cos x bracket squared. Okay, so we can differentiate using generalized power rule. Okay, so when we differentiate y with respect to x, it becomes dy over dx. Okay, and when we differentiate cos x bracket squared, okay, we can use generalized power rule. Okay, we move power to the front here, right? And then we copy the function inside bracket, right? And after that, from the original power, okay, we minus 1, okay, so we get the power of 1, right? And after that, we differentiate the function in bracket, okay, so we differentiate cos x. From trigonometric rule, derivative of cos x equals to negative sin x, okay, so we get this, right? And after that, we can simplify. So we have negative 2 sin x cos x, okay? Or we can write negative sin 2x. This comes from double angle identity. Sin 2x equals to 2 sin x cos x. That's why we get this, right? And then from here, okay, from the first derivative, okay, we can differentiate again. Okay, from dy over dx equals to sin 2x. So when we differentiate, the symbol becomes d2y over dx2, which is the second derivative. Okay, so we keep the constant in front, negative in front here. Okay, and then we differentiate sine to x. We can refer from trigonometric rule. When we differentiate sine single x, it becomes cos single x. So when we differentiate sine to x, it becomes cos to x, right? But after that, we need to differentiate to x. Okay, we differentiate the angle. The angle now is 2x. Okay, so when we differentiate to x, it becomes 2. Alright? And then we can rearrange. Okay, so we have d2y over dx2 equals to negative 2 cos 2x. So this is the second derivative of y equals to cos squared x. The answer is d2y over dx2 equals to negative 2 cos 2x. Right? So this is the final answer. Alright. Let's say if we start from here, okay, we start from derivative of dy over dx equals to negative 2 sin x cos x. We differentiate from here, okay, without changing to double angle identity. Alright, so from here we have multiplication between negative 2 sin x and cos x. So when we differentiate, we need to use product rule, right? So our u equals to negative 2 sin x and our v equals to cos x. Then we differentiate to find u prime, and then we need to find v prime, right? And after that, we use product rule. Okay, from product rule formula, okay, after we differentiate dy over dx, the symbol becomes d2y over dx2. And then from product rule formula, it is equals to vu prime plus uv prime, right? And then we substitute v times u prime, so we have negative 2 cos squared x. And then minus minus become plus, okay, 2 sin squared x, alright? And then we can factorize constant negative 2. So in bracket, we have cos squared x minus sin squared x. Okay, to check whether we factorize the correct function, so we can try to expand. So when we expand, we have negative 2 times cos squared x, we get negative 2 cos squared x. Negative 2 times negative sin squared x, we get back plus 2 sin squared x. Means that we factorize the correct function, right? And then from here, okay, cos squared x minus sin squared x equals to cos 2x. So we can write into the form of negative 2 cos 2x, or we can move out we can eliminate the parentheses, so we have negative 2 cos 2x. Okay, we get the same answer. Alright? Okay, we get the same answer from here. Alright, now look at example 2. Find f(3,5) if fx equals to square root of x minus 1. Right? Because fx equals to square root of x minus 1 equals to x minus 1 the power of 1 over 2. Right? Using generalized power rule, okay, when we differentiate fx, the symbol becomes f prime x. Okay, and then from generalized power rule, we move power to the front here. Okay, and then we copy the function in bracket. Okay, and after that, from the original power, we minus 1. So we get negative half. Okay, and then we differentiate the function in bracket. Okay, but it is equals to 1, so no need to write. Alright, and then from f prime x, we can differentiate again, and the symbol become f double prime x. Okay, and then we can use the same technique using generalized power rule. So we get negative 4 bracket x minus 1 the power of negative 3 over 2. Okay, and then we can continue with f triple prime x. Okay, f triple prime x we get from differentiate f double prime x. Alright, find f3 here means find the third derivative, okay, or f triple prime x, okay. And then again, we use generalized power rule because we have bracket the power of any value such as fraction, negative numbers, or negative values, or big numbers, okay. So we can use generalized power rule to differentiate, okay. And then after we differentiate from f double prime, we have f triple prime x equals to 3 over 8 because we multiply negative 3 over 2 and negative 1 over 4 here. And then x minus 1 the power of negative 5 over 2 because from negative 3 over 2 we minus 1. That's why we get the power of negative 5 over 2 here, right? So now we done differentiate third times, alright? Okay, and then after that we can find f35, okay? So hence f triple prime 5 equals to, we just replace 5 into variable x here, okay? So we have 3 over 8 and then 5 minus 1 the power of negative 5 over 2. So f triple prime 5 equals to 5 minus 1 is 4, okay? And then from 4 we can write 2 squared, okay? And then we can eliminate 2 here, okay? Under properties of indices, if we have power and then bracket power, so we can multiply the power or the exponent. So we have 2 and then the power of negative 5, okay? Because we simplify 2 from here and 2 from denominator of the power here, okay? And after that, we get f triple prime 5 equals to 3 over 8 times 1 over 2 the power of positive 5, which is equals to 3 over 256. Okay, this is the answer when we find f3, 5, right? For fx equals to square root of x minus 1, right? Coming up next, linear approximation using differentials. You can subscribe, like, and share to support this channel. Thank you for watching. Stay tuned. Bye. Assalamualaikum.